Hi, welcome back to the vlogs.
Okay, 6.5, we're going to talk about incenters. Okay, the incenter is the point of concurrency of an angle bisector. Okay, now listen, this is the only one where the angles are being bisected, where the angles will be marked. Okay, incenters go with angles. Incenters and angle bisector. Concurrency and angle bisector theorem says this. The angle bisector of a triangle intersects at a point that is the same distance from each side of the triangle. So, if segment AD, segment BD, and segment CD are angle bisectors, then that means that DE, DF, and DG are all congruent. And look at those lovely little triangles they made in there for you to solve stuff. So if it's coming and bisecting the angle, that means the angles will be marked, okay? They would be marked like this to show you that they're angle bisectors. Well, maybe, why is it so delayed when I first start? Okay. They would be marked like this to show you that the angles are bisected, right? Or, and then like green, okay? So they're gonna show you. If the angles are bisected, you have something that happens to be called an incenter. And the incenter, okay, creates three perpendicular bisectors with the sides that are equal. Okay, let me see. I think the next screen has the same amount. Let me double check. No, okay, I'll give you a second. So incenters go with angle bisectors. That page I gave you yesterday, it's on there. You should fill that.
He doesn't have it.
What?
He doesn't have it.
Probably because he left his right here on the desk. But not being pulled up. Okay, so incenters is the point of concurrency with angle bisectors. If segment AB, segment BD, and segment CD are angle bisectors, then that means that DE, DF, and DG are all congruent. And I've created nice little lovely triangles inside of a large triangle, and I can start to prove things. Okay, angle bisectors in a triangle. It says if AD is 12, okay, and AP is 13, what is FP? And it says AP, BP, and CP are all angle bisectors. So it says AD is 12, so this portion here is 12, okay? AP is 13, this here is 13. They want to know what is FP, what is this right here? How can I figure that out? What do you know about FP? What do you know about FP? What is it equal to? DP and EP. Can I figure out what DP is?
Yes.
How?
Side, right.
Look at this triangle here.
It's a right triangle.
It's a right triangle.
Pythagorean theorem.
Pythagorean theorem. So if I figure out what DP is, FP is the same thing. How would you set up this equation for Pythagorean theorem? Great, I want to know what your A and B and C is.
13 squared plus B squared equals.
Nope. 13 is your hypotenuse. It is cross from the.
So 13 squared equals 12 squared plus.
Okay, so I get 169 equals 144 plus B squared. So B squared, what is 169 minus 144? 9.
125.
25, right? The square root, and b equals 5. So, segment FP equals 5. Do you see how that works? Does that make sense?
Yes.
Okay, so if you know that they are angle bisectors, you know that FP, DP, and EP are all congruent, which means if you know two things from another triangle, you can start solving. It's pretty simple. Okay, you can work that out. Okay. So angle bisectors make life a little easier. Do not get this picture confused with the altitudes or the perpendicular bisectors, because all of them have right angles listed in them, okay? Don't get that confused. Okay, so here's a little synopsis of what we've done. You have the circumcenter, and the circumcenter goes with what type of bisectors? Perpendicular. You have the incenter, and it goes with angle. You have the centroid, and it goes with, and you have the orthocenter, and it goes with altitudes, okay? Make sure you have that filled out on your chart. What?
Credited by, created by.
Yeah, created by. So when it says circumcenter, it's created by the perpendicular bisector. When it says incenter, it's created by the angle bisectors. When it says centroid, those are created by medians. And when it says orthocenter, those are created by the altitudes. Okay? Angle bisector should be the easiest one because it's the only one that looks that way. It's the only one that has angles marked. Okay? Centroids and circumcenters are marked congruent on all their sides. So you have to know that a circumcenter has perpendicular with it. A centroid does not have perpendicular with it, okay? Orthocenters are just perpendiculars. The sides are not congruent. Okay? So a little bit of a summary of the four. It's hard to keep them separate in your mind. I understand that. Okay? Okay. Summary of circumcenters, incenters, centroids, and orthocenters. Just another quick expanded look. A centroid, okay, is medians, which means I'm cutting the other side into half. Yes? Centroids can meet where at on a obtuse triangle. Okay? Centroids can meet, well, yeah, where at on a right triangle?
Right, but always.
On the hypotenuse.
Oh, cause the right angle is the.
Yep, because that's orthocenters. And centroids on acute triangles meet where? Inside. Okay. On orthocenters on acute triangles, where do they meet? Inside. On a obtuse triangle, where do they meet?
Outside.
And on a right triangle, where do they meet?
Around
The right angle. Okay. I don't know. Oh, well. Okay, here we go. So then, just another little summary. Trying to beat this into your head if you can't tell. Okay, so circumcenters, the point of concurrency of the perpendicular bisector. The incenter, the point of concurrency of the angle bisector. Okay? The centroid is the median's point of concurrency. And the orthocenter is the altitude's point of concurrency. You have circumcenters, perpendicular. Incenters, angle. Centroids, median. Orthocenters, altitude. If you notice, the vowels go with the vowels. Incenter, angle, orthocenter, altitudes. Okay? Circumcenter, perpendicular, centroid, medians. Okay? You have to be able to distinguish those. So we're going to work on some homework.
I'll stop it. I'll stop it. No, don't stop